So hello everyone. So in the previous video, I covered how the a value here affect the function f(x equals x squared). So basically, if you have the a value equals to -1, you will see that the function is reflected in x-axis. So the y equals x squared function is reflected in x-axis, and also we look for how would a value increase from 1 to infinity affect the function y equals x squared. So basically, when a value is greater than 1, we expect to see that the x component of the quadratic function is constricted, it becomes smaller. When a value is between 0 and 1, we could see that the x component of the quadratic function is expanded, so it's become more greater. So basically, the higher the a value, the more constricted it is. So basically, y equals 4x squared is more constricted than 3x squared, than 2x squared, and x squared. And also we found that for a value between 0 and 1, we could see that the smallest fraction here would be the wider x component, and this one would be less y. So what happens if the a value is negative? So if a value is negative, we expect to see that the parabola is heading downwards, that if I increase the a value, the x component become more smaller and smaller each time, right? So we see that. So when a value is -1, you will see that this shape is reflected in x-axis and it's exactly the same shape. So basically, if I further decrease the a value, you will see that the x component become more smaller and smaller and smaller. So basically, if I do the a value and smaller in the negative direction, I get the x component of the quadratic function becomes smaller. When I increase the a value from the negative side, I will see that the function is expanded. So this is a conclusion. The a value is greater than 1 and smaller than -1. The x component of the quadratic function is constricted. If a range is between 0 and 1 and also -0 to -1, we could see that the x component of the quadratic function is expanded. So we have the last one, y equals a s minus p squared plus q. So this equation has both a factor, p factor, and q factor. And how these three factors affect the function we are looking for. So when your teacher taught you this equation, the teacher maybe told you that the vertex of this equation is p and q. So in this video, I'm going to prove you why the vertex of this equation, this function, is p and q. So how do I prove that this function, the vertex, is pq? So basically, I need to assume the constant p and q is positive. So I just need to break this up in two components. So first component, we have y equals s minus p squared. So if you see that, I basically need to transform the y equals s squared function p units to the right. So this is my s squared function, and I'm going to transform this function p units to the right, and I get the vertex point equals to p0. So transforming the function to the left to the right affect the x-coordinate of the function. So that's why x-coordinate of the vertex is affected, is the value p. So basically, I'm going to take this function and then transform q units to the top, and we could see that this function is transformed q units to the top, and this is the equation of the function y equals x minus p squared plus q. So we transform the function, this one, q units to the top, so that's why we got the function, and this point, the vertex, is p and q. So that's why I got the p and q, the vertex, in this example. So the constant a here does not affect the position of the vertex. So we have figured out the vertex form of the equation y equals as minus p squared plus q. So the reason why I call this the vertex form because I can locate the vertex in this example. So in this example, the vertex is p and q. And also if I expand these terms here, I can get this standard form quadratic function y equals ax squared plus bx plus c. So next, I want to cover these four exercises. We have these equations written in vertex form, and I'm going to find the vertex for this situation. So basically, if I want to find the vertex of this function, I need to figure out what is the p value and what is the q value. So the p-value is inside the bracket. So in this case, we have x minus 1 squared plus 2. So the x-coordinate of the vertex is equal to positive 1. So why is it equal to positive 1? Because the bracket, the sign here is negative. So I need to assume that the p-value is positive when the sign inside the bracket is negative. So we have positive 1 for the p-value. So what about the q-value? So q-value is outside constant here, so we have positive 2. So basically the vertex for this quadratic function is 1 and 2. So I want you guys to finish up the remaining questions. So please pause the video and try this out. Make sure you try this out before you proceed. So basically you need to get these answers. So let's go over one by one. So for the second equation, I have x plus 3 squared plus 2. So the x value, the p value is equal to negative 3. So why is negative 3 here? Because the sign inside the bracket is positive, so the p value is negative. And it's negative what? It's negative 3. Because the inside constant is 3, so the p value is negative 3. And the q value is positive 2, right? And for the third one, we have the negative sign inside the bracket, so we have the positive 1 for my p value, and we have negative 2 for my q value because I have the negative sign outside the bracket. So, and for the last one, it's become more tricky. So we have negative 2 x minus 1 squared plus 2. So basically, this equation has the same vertex as the first one, 1, 2. So the negative 2 does not affect the position of the vertex. But be careful, 1, 2 at this point is at maximum point, but it's not necessarily the same at this point. So 1, 2 at this point is at the minimum point.